like to welcome to the stage at this time Andressa de Mello Cabistani, who will speak with us on self-healing system for UI tests using ML. Thank you.
Thank you. So, hi. Oh my God, you're a lot of people. So, hi, my name is Andressa Cabistani, and I am not a machine learning engineer, nor a data scientist. I work as a software quality engineer, and I want to show today that there are things we can do using machine learning in my area too. So today I'll talk about the self-healing system for UI tests that we built in my team this year. This system started as a project during an AI hackathon and ended up as a solution to make our UI test suites more reliable. But before I start, let me introduce myself a little bit. So as I said, my name is Andressa. Probably you already know that because of my accent, but I am Brazilian. Brazil is doing an out-of-season carnival right now, celebrating that the former president was sentenced to 27 years of prison for attempting a coup d'etat. So, yay, Brazil. I work at Red Hat, and I love programming. What I like the most about programming is the fact that we are always learning. When I'm not working, I am probably singing K-pop Demon Hunter songs with my daughters. Those are they, by the way. I didn't just get images from random girls in the internet. And the last thing is that I love Star Wars. But who doesn't, right? So, enough about me. Let's do a quick overview of how a UI test works. Basically, we need to use an automation framework, for example, Selenium, or the one I built this whole project around, called Playwright, and tell the automation framework to identify a specific element in the page and perform an action in that element. An example to understand that is if I have a test to validate that the logging functionality is working in a page, I tell the automation framework to navigate to the page under test, select the username input box, and fill that with the correct username. Select the password input box, and fill that with the correct password. Click the login button, and then assert that the login functionality was successful. Or like the example in the slide shows, go to the PyCon Australia 2025 website and click the link identified by that huge CSS selector, which is the About link in that page. To add some context about Python Playwright, the first thing to understand is that Python Playwright has a page class with methods that are used to locate elements in the page. For example, getByRole, that receives the type of role, like button, and the name of that button, for example, submit. These methods return a Playwright's locator instance. The locator instances make it possible to click, fill, check, and perform other Playwright actions. In this slide, we can see a video I recorded of myself pointing to the mouse cursor to different elements using Playwright code generator, just to show some of the ways Playwright uses to identify elements in a page. For example, the getByRole, passing the link as role and setting name about as an alternative to calling locator method and using that long, awful CSS selector from the other slide. And please take a good look at that About link in the page, because I'll talk about it a lot today. So when we are testing something, like the logging functionality, we call it an end-to-end test. And if I have a test suite full of end-to-end tests that are triggered in a CI/CD pipeline to run every time new pieces of code are merged, we call them regression tests. These regression tests run so we can lower the risk that the changes affect other functionalities before continuing its way to prod. And when a failure occurs in this regression test, we stop the release of the functionality and start to investigate what happened. And here is where the UI test problem begins. Sometimes, even a small front-end change to an attribute can break a selector, making it impossible for an automation framework to identify the element in the page, to perform the expected action until a timeout error occurs. So we stopped the whole pipeline, started to investigate what is wrong, just to find out that the ID changed from hashtag username to hashtag user. And this doesn't affect the logging functionality. The logging is still working. It's just a UI test framework limitation. So as good engineers, we wanted to create a solution for this problem. A system that, when a timeout error occurs during an action like click, fill, check, etc., because Playwright couldn't find the element, the test would heal itself. Sounds a lot like a Jedi mind trick, right? It will heal itself and make the pipeline succeed. It is not as cool as a Jedi mind trick, but we can do cool flowcharts with it. So let's start with the successful case. The test starts and tell Playwright to perform the action click in an element. If Playwright is successful to click in the element, fingerprints for the element are saved in a database, and the test will continue. Now, the case that interests us more. The one that the action wasn't successful. In this case, if Playwright can't find the element, the healing is triggered. When the healing is triggered, there are a bunch of things that need to happen before attempting to heal. The first thing in the healing process is to extract information for the failed element so the system can search in the database for similar fingerprints. After finding similar fingerprints, multiple alternatives are generated and sent to an endpoint, where they will be classified and ranked by confidence score, a number that expresses how likely they are to be a successful substitute. The healing system will iterate over the ranked alternatives and start to test them one by one. Both successful and unsuccessful healing events will be stored in the database for future learning. The healing system will try until an alternative is successful or until it exhausts all alternatives with confidence score equal or greater than the threshold, which is defaulted to 0.5. Water. Okay, so since we wanted that our existing test suites using PyTest Playwright didn't need many changes when starting to use the self-healing system, we implemented a wrapper around Playwright's page called self-healing page, which is very creative. And if in the normal Python playwright, we have a page object and all methods used to locate an element return a locator instance, self-healing page has all the same methods, but returning a self-healing locator instance. And self-healing locator implements the same interface as locator, but with the healing functionality inside all methods. The action methods, actually. So in this slide, we can see a comparison. We can see the changes needed to initialize a PyCon AU page instance for a system using only PyTest Playwright without the healing functionality, and how to initialize using the healing system. Without any healing, we just need to pass the page fixture to PyCon AU page, and it's ready to be used. The second way, we need to create a page object with healing capabilities, which I called self-healing page in Snake case. Since we can't pass the fixture page from PyTest Playwright directly to PyCon AU page, we pass it to the class self-healing page to build a page with healing capabilities that we want to pass to PyCon AU page. Self-healing page will accept both page and the healing DB as our arguments. After that, we just pass self-healing page object to PyCon AU page, and the fixture is ready to be used. So all the tests using the fixture PyCon AU page won't need to change. The only changes were in how to set up the fixture, and all methods used are compatible with both pages. So we already know from the flowchart what is the flow of the system. But what happens in the code when I use the fixture PyCon AU page with healing capabilities inside my test and tell Playwright to click in that About link? First, the getByRole method inside self-healing page will return a self-healing locator. If you paid attention in the About link, like I told you to do, you already know that they are doing to locate the About link in the page is a good way. So the click action is successful without any trigger to the healing system. And when an action is successful, the action method will call the method to insert the fingerprint and save the successful interaction in a database. And save all and store all these fingerprints in the database. But what are those fingerprints? Oh, just a second. I am running. Okay. Okay. So what are those fingerprints? So these are information about the element we just clicked. These information are tag name, which is an A here for a link, or what's the inner text, which we know it's about, or if there are accessibility attributes, or the page this element is located, and the type of locator method it is used to get that element. And these are all important information that we will need as soon as the locator is not valid anymore and needs to heal. But now, let's simulate a failure. So, inside our test, we are trying to locate an incorrect name ABT. Well, we know this is supposed to trigger a healing, but in code details, what happens? The timeout error is handled inside each action method in self-healing locator. So when the timeout error happens during the click, it will first check if the healing service is available, and if it is, it will attempt to heal. The first step when the system is attempting to heal is to get more information about the failing element. The extract element context is called, and the first thing it does is to start a dictionary called context with default values for each fingerprint. After that, it extracts the exact page the element is supposed to be and add to the context. And it's possible to try and get more elements from the body in that page. It's possible to infer some data about that element too. From the row link, for example, it's possible to infer that the tag name is probably A. After adding all this information in the context dict, it returns the context. Now, it's time for the healing system to generate all possible alternatives for the failing locator. The dict context was passed as argument and is used as base to query the database to get similar fingerprints. The similar fingerprints are passed to strategies to generate an exhaustive number of possibilities. And it can be a really big number of possibilities. For the example we are working on here, it suggests 133 alternatives. A lot of is rubbish, of course, but that's not for me to classify them as rubbish. That's the job for random forest classifier. Sending 133 alternatives wouldn't be very easy to add in a slide, so I just added some good alternatives and some not so good alternatives to call, and did a call to the endpoint where the model is being served. The model then classified all of them. Let's start analyzing the first one. It's 0.92. It is a really high confidence score. The one I used before as an example of successful is the third one and is classified as 0.91. Again, very high confidence score. And we can see that the weirder it gets, less likely to succeed it is. The endpoint not only returns all alternatives classified, but also returns a ranked alternatives list organized from the most likely to succeed to less likely. And this is good because as soon as the healing system finds a good locator, it just stops. No need to try others. Scikit-learn random forest classifier is a supervised machine learning algorithm, which means it learns from historical examples where we already know the correct outcomes. In the self-healing system case, this means training on thousands of past UI healing events that are labeled as either success or failure. The algorithm builds hundreds of decision trees, which are the forest, where each tree is trained on a different random subset of this historical data and uses a random selection of features at each decision point. When making predictions, all trees vote on the most likely outcome, and the majority decision becomes the final prediction. Basically, uses the wisdom of crowds principle that an idea of an individual can inherently be biased, But taking the average knowledge of a crowd can result in eliminating the bias or noise to produce a clearer and more coherent result. So English is my second language. So since machine learning, oh my God, it's getting hard. So since machine learning algorithms can only understand numbers, we need to convert everything about a UI element and its alternatives into numerical representations. For example, when a test fails on a selector like get by row, link, name, ABT, the healing system doesn't just see text. It sees measurable characteristics. And the transformation from human-readable information to numerical data is what allows the AI to make mathematical comparisons and predictions. The self-healing system extracts 85 different distinct numerical features across 6 categories, each designed to capture different aspects of what makes a good healing choice. The selector features converts basic characteristics of the selectors in numbers. For example, string length becomes a character count. Complexity becomes a numerical score based on how many conditions and nested structures exist. For example, a simple ID #submit button gets a complexity score of 1, but that nested selector in the slide gets a complexity score way higher because of multiple condition and nesting. The similarity features that transform the concept of how similar are those two selectors into precise numerical measurements using Jacquard similarity. Jacquard similarity compares two sets of data and returns a percentage from 0 to 1 that express how similar they are. Basically, it's the ratio between the number of observations in both sets and the number in either set. So we can see that after excluding repeated characters from both sets, the Jacquard similarity is very high, because only the U in about is different. Also, since from ABT to about, there are only 2 characters added. The added distance between the 2 words is 2. And there are also semantic similarity features that checks ABT and about, and ABT and sponsor, and understand that ABT and sponsor are too unlike to be the same element. But about is very likely to be the link name playwright is looking for. The context features converts environmental information about the web page and HTML elements into numerical form. Look all the extracted information for PyCon AU web page in the home path and about path. Just from all this information, the system already knows these are 2 different paths. In these context features, the HTML element type become categorical numbers where button equals 1, input equals 2, link equals 3, etc. So when healing fails on get by row, link name ABT, the system knows it's targeting a link element and can factor that into its healing predictions. Now, what I believe to be the most sophisticated transformation, the reliability features, they convert best practices for selectors in numerical scores. The presence of an ID selector uses ID selector equals 1, good for reliability, and receive a penalty for and fragile patterns like nth child receives a penalty for bad reliability. Role-based selectors like getByRole, link, name, about get positive reliability scores because they use semantic HTML roles rather than brittle CSS paths. The system literally counts things like nesting depth, selector nesting depth equals 3, attribute conditions, and CSS combinators to create numerical reliability indicators that predict selector stability. The DOM features analyze where an element is within the page's hierarchical structure, like the address of an element in the HTML document. When a UI test fails, knowing the structure context helps predict which alternative will work in the same location. The features transform this address into numerical data, also creates binary flags from parents' information to know if it is inside a form, a nav, or a container. This is important for healing because elements within forms typically uses semantic attributes like name or ID. So if the element has form parent, the model knows that should prioritize form-specific selectors. The last category are the text features. The text features analyze the actual readable content associated with UI elements. Example of the text about for that link. Text content is often the most stable aspect of web interfaces, while CSS classes and DOM structure frequently change. User visible labels like about tend to remain consistent. The system examines the inner text and text content to create multiple numerical features, like if it has an inner text, the length of the inner text, the length of the text. Also checks if the text is numerical or if it contains spaces. And this is important for healing because knowing that has an inner text like about, it makes getByRole, link, name, about a preferred alternative when healing the failing element. Finally, let's see in practice how this works. I have a video here for a test without the healing. So this will take a while. Spoiler alert, it will fail. It will trigger a timeout error. I am running out of time, so I will just move it forward. OK, so a timeout error occurred. Yeah. So now we are going to see how it works in a test. Oh. With the healing. And I will move forward because it takes like around 30 seconds to the timeout error starts. And the healing, and then it will just like click around the page and do another things and then boom, successful. So final considerations really quick. To finish this talk, there are a couple things I want to mention about what is the future for this project. So this was trained with synthetic data. So now, from moving forward, as more healing events start to happen in our tests, more data we will have to retrain the model and then refine this model later. And this is important because when it's a powerful thing to have synthetic data generated, but they are not very good for real problems. So as soon as we have more real data, the model will be refined. And also, the other consideration is a notification system, because we want that for a pipeline. We want the pipeline to succeed, but we don't want to keep healing all the time. So we need to not be notified when a healing is happened, so we can change the code, right? We don't want to keep using these healings all the time. So okay, so thank you. That was my talk, and I probably don't have more time now for questions, but I'll be around if needed to talk about it. Thank you.